So welcome everybody to this latest video 162 Maths, and in this video we'll be going over the AS Maths Mechanics topic of kinematics with variable acceleration. In other words, using kinematics with differentiation and integration. Now, if you've already studied basic kinematics, in particular looking at displacement time or velocity time graphs and all the formulas and all the features of what each attribute represents as shown on the examples on the screen, then you should know that so far these plotted lines have one thing in common, and that is that all the lines are straight. Now, a question you may be asking yourself is, why are they straight lines? Well, there's a simple reason for that, and that is because acceleration is constant or velocity is constant depending on the graph in question. Now, if acceleration or velocity was not constant, then the straight line will simply be replaced by a curve. However, all the attributes and all the features would still remain the same. Now, a key thing to note is that if acceleration is not constant, then the SUVAT formulas will not work, and without straight lines, this makes it difficult for us to find the gradient at a particular point, typically using m equals y2 minus y1 over x2 minus x1, and finding the area under the lines using triangles, rectangles or trapeziums. However, we can use differentiation and integration. Now, with curves, because the gradient at any particular point is changing and the area enclosed between the x-axis is not consistent, then we can use our skills in working with differentiation and integration to find these out. Now, if gradient of a displacement time graph equals speed, then v equals the differential of speed over differential in time, which basically converts to ds over dt. And if we look at a velocity time graph, then what causes speed to change is acceleration, so a is going to equal dv over dt. Now, the key thing to remember here is that whenever you see the words of constant change in acceleration, this basically translates to variable acceleration. So if we look at the equation of a line plotted on a displacement time graph, then what this equation of the line represents is s in terms of t, and the gradient of this particular line represents the velocity. So therefore we can then work out the gradient function of velocity on a displacement time graph by differentiating it. So what I can do is, to get from displacement to velocity, I need to differentiate. And what I know from this is then that v equals the differential of ds over dt. Now, if we look at the equation plotted on a velocity time graph, and I draw a particular line there, then the equation of this line is going to be v in terms of something t. Now, if I was to work out the gradient function, and I work out the gradient function by differentiating it, then what the gradient function is going to give me is the formula for acceleration. So if I differentiate v in terms of t, then that is going to give me a formula in terms of acceleration. So that means that a is going to equal dv over dt. So if I know the equation of each of those, I can then work out the gradient function at any particular point of those. Now, if we can differentiate going down from s to v to a, then we can reverse this process by integrating. So from this, what we then can do then is, if I know the formula for acceleration, I can integrate this to give me a formula in terms of v. So what we know then is that v is equal to the integral of a when we are differentiating with respect to t. And also, if I then got the formula for, or the gradient function of velocity, then I can integrate this to go back to the equation of displacement. So if I integrate v, then displacement, which is going to be represented by letter s, is going to equal the integral of v in terms of dt. Now, this is a really important proof for you to remember, and many times the student will ask me, well, how do I remember all of this? Well, an easy way to remember this is, if you think about kinematics, you're automatically going to think of SUVAT. So if I just slowly start to write SUVAT, and if I kind of just ignore the u and the t, then here I'm going to get SVA, which is the order in which we are working with. Now, in terms of knowing when to differentiate, when to integrate, well, if I go down from each of those letters and down, also beginning with the same letter as D as differentiate, then I know then I need to, if I'm going to go down those letters, I need to differentiate. And then likewise, if I'm going up, in which I'm going to draw an arrow going up, then I need to integrate. So I would always start a question by writing this just so that you don't forget when to integrate and when you need to differentiate. Now, before we get started working through some examples, just a little reminder on some key vocabulary that's used quite commonly in these questions. Now, whenever you see the word asked or using instantaneous velocity, that is basically the gradient at a particular point on a displacement time graph, in which how you then go about doing this is first of all find the gradient function of the line and then substitute your t value in. If you're asked to find or any mention of average velocity, well, this is the gradient between 2 points on a displacement time graph. So here what we'd need to do is look at the 2 points, work out the change in the displacement and have this over the change in time. And again, let me just make a little note of that. So this here is going to be the change in displacement over the change in time. And again, these two things will come up in the examples that we're about to do. So let's have a look at our first example. So the question says a toy car moves so that its displacement s meters from a flag after t seconds is given by the equation of s equals 2.1 plus 1.7 t squared minus 0.2 t cubed. And the first part of the question is asking us to find the instantaneous velocity and the acceleration of the car after 5 seconds. Now for this, again, just before we get started on this question, let's just highlight a couple of things. Now, one of the areas that a lot of students usually ask me is how do you know when a question that's quite similar to another topic is a particular area? Well, here, this reads like a bit of like a SUVAT question, but because we're not given the parameters and more importantly, we're given an equation, this is where it then enters this part of kinematics. Now for this, one of the nice things about this area of kinematics is that unlike with SUVAT, there is no need for you to draw a diagram. So we don't need to draw a toy car, we don't need to draw where the flag is, we can just go straight into the question. Now the first part of the question is asking us to find the instantaneous velocity and the acceleration after 5 seconds. And as previously mentioned, that this word instantaneous velocity and acceleration is going to be those values at a particular point, and this particular point in question is when t equals 5. So in terms of the steps of what we need to do to answer this question, so the first part is we need to find the equations of v and a, and then step 2 is then we need to substitute t equals 5. So they're the two steps that we're going to do to answer this particular question. Now, one thing that I always like to do in these questions is I always like to write the equation, all the important information, just so it's a lot closer to what I'm actually working with. So here we've got the formula of s equals 2.1 plus 1.7 t squared minus 0.2 t cubed. And I'm just going to put a little box around that in case I need it for future questions, because a lot of the working out that we do is going to seem very, very similar and I don't want it to get lost. Now, as mentioned previously, a good way to start these questions is to start by writing SVA. And to get to each of these, I need to differentiate, and to get from to the value above, I need to integrate. And that's just going to be in the side of my mind if ever I need it. So back to this question. So I've been given the value of s. So to find, so with part A, I know that v equals ds over dt. So what I need to do is I need to differentiate s with respect to t to give me v. So v is going to equal, if I differentiate that purple box, it's going to give me 3.4 t minus 0.6 t squared. And again, I'm going to put a little box around that. Then the next thing I then need to do is I need to work out the formula for a, and a is equal to dv over dt. So if I differentiate that red box, I'm going to get a equals 3.4 minus 1.2 t. And then all that's left for me to then do is substitute t equals 5 into those respective boxes. So when t equals 5, v is going to equal 3.4 multiplied by 5 minus 0.65 squared. And that's going to give me a v value of 2 meters per second. And again, don't forget the units. Then if I substitute t equals 5 into the a, then we can get 3.4 minus 1.2 multiplied by 5, and that's going to give me an acceleration value of negative 2.6. Again, don't forget the units for this, which is meters per second squared. Then for part B, so let's just rule off from there. So with regards to part B, it's then asking me to find the initial displacement of the car from the flag. Now for this particular question, what I need to do is I need to, whenever you see the word initial, it's usually going to imply that t equals 0. So initial implies that t equals 0. So for this, I need to try and find the initial displacement. So for B, I need to find s when t equals 0. Now for this, I'm going to need the formula for s. So when t equals 0, s is going to equal 2.1 plus 0 minus 0. So s equals 2.1, and the units for displacement here are going to be meters. Then finally for part C, it then says the average velocity during the first 5 seconds of the motion. So for this, with regards to C, now as mentioned before, we have that average velocity is equal to the change in displacement, which is s, over the change in time. So in other words, what this is, it's the s at the end minus s at the start over t at the end minus t at the start. So working then with part C, we're working for the velocity of the first 5 seconds. So we're finding the average velocity between t equals 0 and t equals 5. So the average velocity is going to be s when we substitute t equals 5 minus s when t equals 0 over when t equals 5 and the starting time, which is 0. Now when I substitute, so when t equals 0, well, I've already worked that out as being 2.1 from part B, and when t equals 5, s is going to give me 19.6. So here then the average velocity is going to be 19.6 minus 2.1 over 5. And if I type that all into my calculator, I get a final answer of 3.5 meters per second. And there we go. So now let's have a look at our second example. So it says S is measured in meters, T in seconds, V in meters per second, and A in meters per second squared. Now typically a question might give you the units of what they're working with, or it may be implied in some of the information that's given in the equation. So it's certainly something that's worth looking into when you are working through these questions. Anyway, back to the question. It says a particle moves in a straight line. Its displacement from the point A is given by S. Find the equation for the velocity and acceleration in terms of t when s equals t to the power 4 minus 3t squared and plus 4t. And the first part of the question is asking us to find the equations of v and a in terms of t. So again, as per, let's start by writing out the equation of s. So s equals t to the power of 4 minus 3t squared plus 4t. Again, put a little box around that so we know, and we can make it a little bit obvious that that's the formula for S. So then to work out V, before we start, let's start by writing out SVA. So we know what we're doing. So here, to find V, I need to differentiate S. So V equals ds over dt. So let's just put that in a little bubble. And so here, what I get is I'm going to get V equals 4t cubed minus 6t plus 4. I'll put a little box around that. And then to work out what A is, so A equals dv over dt. So to work out A, I differentiate what that red box is. So that's going to be 12t minus 6. And there is my answer for part 1. Then for part 2, it's then asking me to find the instantaneous velocity and the acceleration when t equals 3, or after 3 seconds I should say. So what this question is asking us is to find V and A when t equals 3. So all I've got to do is just substitute the values into those two respective formulas. So when t equals 3, V is going to be 4 lots of 3 cubed minus 6 lots of 3 plus 4, and that's going to give me a V value of 94 meters per second. Then working with when t equals 3 to find out what A is going to equal 12 lots of 3 minus 6. So A is going to equal, and that's going to be, oh, I forgot a squared there, and that's going to be 12 times 9 minus 6, which gives me an answer of 102 meters per second. And there's my answer for that one. Then for part 3, it's then asking me for the average velocity after the first 3 seconds. So that's when t equals 0 and t equals 3. So the average velocity equals s when t equals 3 minus s when t equals 0 over the end time, which is 3, minus 0. And again, you might think, well, what's the point of writing 0? Well, if the question asked to find the average velocity between the seconds of 7 seconds and 11 seconds, then I'll need to do 11 take away 7, which would give me 4. So again, the denominator may change depending on the question and how it's written. So back to the question, what we need to then do is know that when t equals 3, s is going to equal 66, and when t equals 0, s equals 0. So the average velocity is going to be 66 minus 3 over 3, which then gives me an answer, over 0 rather, which gives me an answer of 22 meters per second. And there's my answer for part 3. So now let's give you one for you to try. So it says that S is measured in meters, T is measured in seconds, V is measured in meters per second, and A is measured in meters per second squared. It says the particle moves in a straight line. Its displacement from point A is given by S equals minus 0.5 t cubed plus t squared over 3. And the first part of the question is asking us to find the equations of velocity and acceleration in terms of t, find the instantaneous velocity and the acceleration after 3 seconds, and for the final part, find the average velocity for the first 3 seconds. So if you want to pause the video, have a go at this question and then unpause as I go through the answers. So looking through this then, what we should have is, so for part 1 you should have a V formula of V equals negative 1.5 t squared plus 2/3 t. Now you might be tempted to write either, I know before we always try to, as mathematicians, we always try to keep it consistent of either writing coefficients in decimals or in fractions. In this particular topic, sometimes you can write it in both. So if you end up with a reoccurring decimal, then just convert it into a fraction. And if you've got a terminating decimal and you don't mind writing it down, then write it down. But the key thing is, whenever you're writing an equation or a formula, you want to try and get the most accurate values. So try and use the exact values where possible. So going back to the question, we should have an A equation of A equals minus 3t plus 2/3. Then for question 2, you should have a V value of minus 11.5 meters per second. Again, don't forget the units, and an A value of negative 25/3 meters per second squared. Then for question 3, you should have an average velocity for the first 3 seconds of negative 3.5 meters per second squared. So now let's have a look at our next example. So it says, for each of the following, find the expression for velocity, calculate the initial position and initial velocity, and for the final part it says, find the time and position when velocity equals 0. So for this, let's start with A, which I'll do my red pen. So with regards to A, we've got S equals 5 plus 3t minus 2t squared. Now this is really important that you make sure that your 5s look like 5s and your S's look like S's. I know with my handwriting it can look a bit confusing, so as long as you know what you're doing, that's fine. So for part I, what I need to do is I need to find out V. So V is equal to differentiating S in terms of t, in which we're going to get 3 minus 4t. So V equals 3 minus 4t. So there's my formula for I. Then for part 2, it says calculate the initial position and the initial velocity. So for the initial position, so initial position means find S when t equals 0, and the initial velocity is asking us to find V when t equals 0. So for part 2, what I need to do is just substitute t equals 2 equals 0 into the two formulas that I've got written. So when t equals 0, S is going to equal 5 meters, and when t equals 0, V is going to equal 3 meters per second. Then for part 3, it then says find the time and the position when velocity equals 0. Now for this, the instructions I need to do to find this is I need to find, well, in order to find the time when, I need to find t when V equals 0, and then from this what I then need to do is then sub this t value into S. So for part 3, what I need to do is make V equal to 0. So that's going to be 3 minus 4t is equal to 0. So that's going to then give me a t value of 3 over 4. And then what I then need to do is substitute that t value into S. So S equals 5 plus 3 lots of 3 over 4 minus 2 lots of 3 over 4 squared, which I then just need to type that into my calculator, in which I get an S value of 49 over 8, and that's in meters. And there's my answer for that one. Then for part B, well, for part B, if you wanted to have a go at this, just pause the video and have a go, and I'll just go through the answer as soon as you've unpaused it. So for part B, we just need to repeat the same, but this time for a different equation. So for B, we've got S equals 4t squared minus 3t. So for part I, we just need to differentiate this to get V. So V is going to equal 8t minus 3. Then for part 2, I then substitute, so when t equals 0, V is going to equal negative 3. And when t equals 0, s is going to equal 0. Then for part 3, I make v equal to 0, so 8t minus 3 equals 0. So t is going to equal 3 over 8. And then I substitute that t value into s. So s equals 4 lots of 3/8 squared minus 3 times 3/8. And then plop that straight into my calculator. In which I should get an S value of -9 over 16 meters, which as a decimal is minus 0.5625 meters. And there we go. So now let's have a look at this example here. So it says an object moves in a straight line with an acceleration given by the equation of a equals 3t squared minus 6t meters per second squared, where t is measured in seconds and the initial velocity of the object is 1.6 meters per second. Now for part A, it's asking us to find the equation of velocity of the particle. For B, it then says find the equation of the displacement from the initial position at time t. And then for part C, it's asking us to find the displacement and the velocity of the object after 2 seconds. So for this, what we need to do is, first of all, now before we get a bit complacent, let's always start by writing SVA and how we get from each of those equations to the other. Now in this particular question, what I've been given is I've been given the formula of A. So in terms of this, now the fact that they've given me 3t squared minus 6t in brackets is just so that you're not getting confused with ms to the power of minus 2 as a variable. That's the unit. So what we want to do then is just make sure we're not going to get confused by that. So if we start the question, so in terms of the solution, let's start by writing a equals 3t squared minus 6t. Let's put a little box around that. So the question's asking me for part A is to find the equation for velocity. So to get from A to V, I need to integrate. So V is equal to the integral of A dt. So that's what I'm going to do. So what I need to do is I need to integrate in terms of t that box of the equation of A. So V is going to equal the integral of 3t squared minus 6t dt. So if I then go on and integrate this, then what I'm going to get is I'm going to get v equals, and it's going to be 3t cubed over 3 minus 6t squared over 2 plus c. Now when it comes to integration and kinematics, it's really important that you always write your plus c. So let me just make a little note of that, is don't forget the plus c. Now what we then need to do, now you might think to yourself, well, the only thing that's left for me to then do is to maybe simplify, in which you can, in which what I get is I get a formula v equals t cubed minus 3t squared plus c. Now it won't be explicit in the question, but what you need to do now is to find the value of c. So don't leave any equation with c. Now what you need to do in order to find c is we need to use this information here to find c. So use this to find c. Now in terms of what I've underlined, the initial velocity, so initial velocity equals 1.6 meters per second, and what that means is that when t equals 0, v equals 1.6. So to find c, use when t equals 0, v equals 1.6. And it's very, very similar to when you would have done direct and indirect proportion. So looking at this, we get 1.6 equals 0 cubed minus 3 lots of 0 squared plus c. And therefore c is a value of 1.6. So the equation of v is going to be t cubed minus 3t squared plus 1.6. And there is my answer for part A. Then for part B, it then says work out the equation for displacement from the initial position at the time. So in order to work out what the equation of displacement is, so for part B, what I need to do is find the equation of S. Now if I know what V is, to get to S, what I need to do is integrate V. So S equals the integral of V in terms of t. So therefore S is going to equal, and if I integrate what's in that blue box, I get t to the power of 4 over 4 minus 3 t cubed over 3 plus 1.6 t plus c. And again, do not forget that plus c. Now this is one of the reasons why it is important you write that plus c, because if I didn't write plus c in the previous part of the question, I never would have got that 1.6, which is going to have a knock-on effect to any future equations that I then need to find through integration. Now in terms of the initial position at time t, well, this is going to be when t equals 0. So when t equals 0, S is going to equal 0. Now because the initial position is when it hasn't moved, so initial position here is when S equals 0. So when t equals 0, S equals 0. So then 0 equals 0 minus 0 plus 0 plus c. So therefore c equals 0. So my equation for S is going to be, and I can simplify what I've written in green, so it's going to be t to the power of 4 over 4 minus t cubed plus 1.6t, and that's it. And I can put a little box around that. Now again, if you want to write it as s equals a quarter t to the power of 4 minus t cubed plus 1.6t, then that again, that's absolute your choice for you to do that, and it will still be marked correct as long as it is. Then for part C, what it's then asking me is to find the displacement and the velocity of the object after 2 seconds. So for part C, all I need to do is to find V and S when t equals 2. So we start off with V. So when t equals 2, V is going to equal 2 cubed plus 3 lots of 2 squared plus 1.6, and that gives me a V value of negative 2.4 meters per second. And when t equals 2, S is going to equal 2 to the power of 4 over 4 minus 2 cubed plus 1.6 times 2, and that gives me an S value of negative 0.8, and that's in meters. And there we go. So now let's have a look at a question for you to try. So it says a particle moves in a straight line with its velocity given by v. The initial displacement from point A is SO. Find the equation for the displacement from A when v equals 1 minus 2t. Now in terms of this here, this is basically a representation of our initial displacement. And what this tells us is that when t equals 0, S equals 1. So that is something that you're going to need to know when working out this particular question. As I said, a good starting point when it comes to these questions is to always start with SVA. To get from one letter to the next going down, we differentiate, and to go up, we integrate. So if you want to pause the video, have a go at this question, and then I'll reveal the answer. So let's have a look at what we should have. So we should have an equation of s equals t minus t squared plus c, and then you then substitute t equals 0 and s equals 1 to find c, in which you get a c value of 1, giving you a final equation of s equals t minus t squared plus 1. So let's have a look at the next example. It says that a particle moves in a straight line with given acceleration a. The initial velocity and displacement from point A is also given. Find the equations for velocity and displacement in terms of t when a equals 4t plus 2. So the first thing I need to do is first of all write down s, v and a. Now although we're given a, and the only thing we can do with a is integrate, so I know what this type of question is going to be. And likewise, in the previous example, in the earlier examples, we had a formula involving s, in which the only thing I can do with s is differentiate it. Only when you're given a formula involving v could you have to integrate or differentiate depending on what it is you're actually wanting to work out. So for this, what I need to do is I need to work out what, from a, I can work out what v is. Now v is equal to the integral of a dt. So integrating a, that's going to give me v equals 4t squared over 2 plus 2t plus c. And then using the information that's given, so using this first one here, what this tells me is that when t equals 0, v equals negative 2. So when t equals 0, v equals negative 2, and I can then find c. So from this, what I then get is I'm going to get minus 2 equals 0 plus 0 plus c. So therefore, c equals negative 2. So the formula for v is going to be, in simplifying it, gives me 2t squared plus 2t minus 2. Let's put a little box around that. Then I can then work out what a is using what I've just found. So then, knowing that s equals the integral of v dt, that s is going to equal, and if I integrate what's in that red box, I get 2t cubed over 3 plus 2t squared over 2 minus 2t plus c. And then using the second bit of information I've been given, so this tells me that when t equals 0, s equals 0. So when t equals 0, s equals 0, find c. I get 0 equals 0 plus 0 minus 0 plus c. So therefore c equals 0. So the formula for s is going to be 2t cubed over 3 plus t squared minus 2t, and that there is my final answer for that one. Now, another proof that you need to know is sometimes you might get asked to work out the change in displacement between times t1 and t2. Now, to do this, all you need to do is integrate v with respect to t between those two limits of t2 and t1. So an example question reads that a particle moves in a straight line so that its velocity at a time t is given by v equals 3t minus t squared. And the question is asking us to find the change in displacement of the particle between t equals 2 and t equals 5. So for this, what I need to do is, if I write down the formula, so I've got v equals 3t minus t squared, and I've got t1 is equal to 2 and t2 equals 5, then to work out the change in displacement, remember that s is equal to the integral of v dt, is then substitute those two limits into this. So what I've then got is 5 and 2 of 3t minus t2, t squared I should say, and that gives me the change in displacement between t equals 2 and t equals 5. So all that's left for me to then do is work this out. So I integrate it first, so 3t squared over 2 minus t cubed over 3. And again, don't need to write the plus c because I'm working with a definite integral. And I'm substituting 5 and 2 into this. So what I then get is I get 3 lots of 5 squared over 2 minus 5 cubed over 3 minus, substituting 2 in, 3 lots of 2 squared over 2 minus 2 cubed over 3. And if I type that into my calculator, let's see what I should get, in which I should get an answer of minus 15 over 2. And as it's in displacement, it's going to be in meters. Now, another way of looking at this is if you didn't remember this particular proof. So if I just draw a particular, if I go through it here, is if I was to plot what this curve actually looks like, it's going to look something like this, where the roots of this is going to be 3t minus t squared equals 0. So that's t lots of 3 minus t. Equals 0, so t equals 0 and t equals 3, so that's going to be at 3. And what I'm looking for is the change in displacement between those two times. So at 2 it's this area here, and at 5 it's going to be this area here. So the change in displacement is the area, so change in displacement of t equals 2 to t equals 5 is the area of the red section minus the area of the blue section. Now for this, where a lot of students go wrong when using this particular method is they then recognize that the areas have got to be positive. So if I was to work out the area of this red section, then that's going to be the integral of between 3 and 2 of t 3t minus t squared dt, and working with the area of the blue area, that's going to be the integral between 5 and 3 of 3t minus t squared dt. Now in this particular question, although we're trying to find the area enclosed between the curve and the x-axis, remember that we're looking with displacement. Now with displacement we can get negative answers, so it is important that when you're working out the separate areas of these, in which we should get an answer for this one, the red area being 7 over 6, the blue area is 26 over 3. So if I then do 7 over 6 minus 26 over 3, I still get that answer of minus 15 over 2. Do not make that answer positive because we're looking at area and you can't have negative area. Here we're looking for the difference between the two. And so the signs is really important. So it's always the area first minus the area second, which is one of the reasons why using this integration between the limits of t2 and t1 of v integrating with terms to t is a lot more easier to do and less likely for you to make a mistake, as long as you've not made any mathematical errors in working out the answer to the definite integral. So moving on to our last question, it says that a particle moves with velocity of v equals t cubed minus 7t squared plus 10t, where t is measured in seconds and v in meters per second. And for the first part, the question is asking us to find the displacement from the starting point after 5 seconds. So in terms of our solution, what this question is asking me to do is to find the equation of S and using a value of to find C at a starting point. And then after 5 seconds. So in other words, when t equals 5. So as always, to start with this question, I start by, because particularly I've given v, then it's worth just making note that to differentiate v, I get a, and to integrate v, I get s. And this is just a case of just working with what I maybe get asked to work out late in the latter parts of this question. So moving on to A, we know that V equals t cubed minus 7t squared plus 10t. So for part A, S is going to be the integral of this. So that's going to be of t cubed minus 7t squared plus 10t dt. So S is going to equal t to the power 4 over 4 minus 7t cubed over 3 plus 10t squared over 2 plus c. Then at starting point, s equals 0 and t equals 0. So what I can then do is I can then work out what c is. So 0 equals 0 minus 0 plus 0 plus c. So therefore c equals 0. So the formula for s is going to be t to the power of 4 over 4 minus 7t cubed over 3 plus 5t squared, and there's my formula for s. So then all that's left me to then do is then substitute when t equals 5, s is going to equal, and substituting 5 into that, I get minus 125 over 12, and that's going to be in meters. Then moving on to B, it says find the times when the particle is instantaneously at rest. So for this, instantaneously at rest basically means that V equals 0. So for part B, V equals 0. So then I get t cubed minus 7t squared plus 10t equals 0. And what I'm going to then do is solve using the calculator, or the polynomial solver that you can do, in which I get t values of 0, t equals 2, and t equals 5. So there is my answer for part BI. Now, just as a little bonus, it's worth just making sure that as we've got 3 values, which is what we expect because we end up having a cubic equation, and the maximum number of roots that a cubic equation can be is 3. Now, this first value of t is the first time that the particle is at rest. This second one is the second time it's at rest, and the 5 is the third time that it's at rest. And the only reason why I'm emphasizing that is because I've seen many questions where they ask you to state the second time that it's at rest, or the third time it's at rest. So the next thing I then need to do is sketch y equals, or should I say v equals, v equals t cubed minus 7t squared plus 10t. So this is going to produce my velocity time graph. Now I've already worked out the roots, so it's going to be at 0, it's going to be at 2, and it's going to be at 5. It's a positive cubic, so it's going to go something like this. And again, let me just correct that because that does not go through 0, and you always need to make sure that it does. So, oh, done it again. Like so. Then for part C, it's then asking us to find the distance travelled by the particle during the first 5 seconds. Now the distance in a velocity time graph, so distance on a VT graph equals the area. So what this question is asking me to do is asking me to find the area of the curve on the velocity time graph between 0 and 5 seconds. Now as you can see, I've got an area that's above the line, the t-axis, and below. So what I need to do for C is I need to work out the area of A and the area of B, and the total distance is going to be those two areas added together. Because remember, it's not asking for displacement here, it's asking for distance, which is the area of those two. So area of A is going to be the integral of t cubed minus 7t squared plus 10t dt between the limits of 2 and 0. So if I integrate that, I get t to the power 4 over 4 minus 7t cubed over 3 plus 10t t squared over 2. I don't need a plus c because I've got a definite integral, and that's between 2 and 0. And if I type that into my calculator, I get an answer of 10. However, what you'll need to do is then show that you've substituted it in. So here you'll need to do 2 to the power of 4 over 4 minus 7 lots of 4 cubed over 3 plus 10 lots of 2. That should be a 2 there. Let me just correct that. 2, and that should be a 2 squared over 2 minus 0, and that gives me an answer of 10. And then I need to do the area of B, which is going to be the integral between 5 and 2 of t cubed minus 7t squared plus 10t dt, which again gives me t to the power 4 over 4 minus 7t cubed over 3 plus 5t squared between the limits of 5 and 2. Again, substituting those numbers in, I'm going to be pretty lazy in terms of this, in which I should get an answer of, and again just type this into my calculator just to check. I should get an answer of 15.75, well, it's actually negative 15.75, so the answer then is going to be 15.75 in terms of the area. And then all that's left for me to then do is add those two distances up. So the total distance is going to equal, and by doing that, by rushing, I've actually recognised that that should be 16 over 3. So the total distance is going to be 16 over 3 plus 15 and 3/4, which gives me a total distance of 21.1 meters. Then all that's left for me then do is to find the average velocity and the average speed. So let me just create a bit of space for that, in which for part D, so the average velocity is going to be the change in displacement over the change in time, and that's going to be minus 125 over 12 over 5, which gives me an answer of minus 25 over 12 meters per second. And then the average speed is going to be the change in distance over the change in time. So that's going to give me an answer of 21.1 over 5, which gives me an answer of 4.22 meters per second. And there is my average velocity and my average time, and there we go.